Okay, we're going to do number 2 on 4.4. A computer base unit of mass 7.5 kilograms is dragged along a smooth desk. If the normal contact force, this is just the normal force, is 23 newtons, and the tension in the arms of the person dragging it acts at a 23-degree angle to the horizontal, then what is the total tension in the person's arms? So our first step is draw a free body diagram, then we're going to set up our net force equations. All right, so our free body diagram for number 2, we have our computer sitting on the ground, so we have a normal force. We have gravity, because it always acts down, and we know we have a tension applied at an angle, 23 degrees. Since we have a vector at an angle, we have x and y components, so we'll call them ty and tx. All right, the other givens we have are the mass is 7.5 kilograms. That gives us an Fg, which is just mass times little g, 7.5 kilograms times 9.81 meters per second squared. Gives us 73.6, let's say. So our Fg value is 73.6 newtons. All right, and then the last thing we're given is, it says the normal force is 23. All right, so we want to find this T. So let's set up our net force equations. And we can actually get away with just doing the y direction for this. So acting in the positive y, we have the normal force, Fn. We also have Ty that acts in the positive direction, so that'd be plus Ty. And Fg is acting down. Okay, and we know it's sitting on the ground because the whole thing is sitting on the desk. So in the y direction, we don't have an acceleration, which means all these forces are at equilibrium. So we want to find T. So if we find one side of this triangle and we know the angle, we can find that. So we want to solve this equation for Ty. So to do that, Ty equals Fg minus Fn. And we just plug in our values, so 73.6 newtons minus 23 newtons gives us a Ty of 50.6. Okay, so what does that tell us? That tells us the size of this component of the full tension. So if we know this component is 50.6 acting at a 23, we can solve for T. So I'm going to draw this triangle just over. So we have Ty here and our 23 degrees. So our trig rule that we would use would be sine. So sine theta equals Ty, so the opposite side over the hypotenuse. And we want to find this T. So to do that algebra, bring T over and divide sine out. So we get Ty divided by sine theta. So that would be 50.6 newtons divided by sine of 23 degrees. So our full tension here, let's see, 50.6 divided by sine of 23. So our full tension is 129.5. On the answer key, it's rounded to 130 for 2 sig figs. So that is number 2.